the diodes. Okay, because if I remove this one, if I make it open circuit, this point is 10 volt, and this is your this will be grounded 0 volt. So open circuit voltage is sufficient to make this diode conduct. But the problem is now both are in parallel. So parallel both cannot be on, because if I on this one, then situation will be like this. If I make on this one, so this will be 0.7, and if I make this is on, this will be 0.3. Now both are parallel, and parallel voltage should be same. So now the choice is only one path can be open for the closed for the current, other will be open. So which diode will be open? Tell me, which diode will be open? Upper one or lower one? So whenever this situation happens, okay, the diode which require lesser voltage, that will become on, or the path or the branch which require lesser voltage, that will be on, other will be off. There are many more questions will come in the coming time of parallel circuits. Okay, so you see, if this is on, so this will be on, this will be off. So this will be treated as open circuit because both cannot be on, and the voltage here will be 0.3 volt, and this 3 volt is not sufficient to make this diode on. Now your current will come from here, it will choose this path and come here. Now if I want to measure the voltage here, say V naught, I can easily find V naught. What will be V naught? Tell me. V naught will be here -10. This plus, I'm coming from this closed path, KVL, plus 0.3, and then plus, this is plus V naught. So V naught will be -10 minus 0.3, 0.9.3 volt. Okay. And now if I want to find what is the current in the circuit, so current in the circuit will be this 9.3,
9.7.
9.7, sorry, 9.7 divided by 10 kilo ohm. That will be 0.97 milliampere. Okay. Now, this was constant model. Up to problems will come now. We will keep on solving the problems. But let me now introduce although one more model is a piecewise linear model. That is also very simple. Piecewise linear model. So piecewise linear model says that you have a diode, okay, and if diode is forward bias, so this diode will be replaced by a battery of 0, if it is silicon, it will be replaced by 0.7 volt, and if it is germanium, it will be replaced by 0.3 plus a forward resistance. Okay, if it is a forward bias, and forward bias voltage is greater than, or not forward bias voltage, the voltage across the diode. Okay, when voltage across the diode is greater than, open circuit voltage across the diode is open circuit voltage, okay, is greater than 0.7 volt, then you can replace this by battery, or if it is germanium, you can replace by 0.3 and a resistance RF in the forward bias. Okay, and the reverse bias case is the same. Reverse bias, okay, if the diode is reverse bias, then you can treat it as open circuit, or sometime a reverse resistance will be given. Reverse resistance which is generally order of mega ohm, very high mega ohm. So that's the same thing, like either you make it open or you put at a high resistance. So current passing through the diode will be very negligible. So that is the same thing. Okay. So it is either it will be replaced. If it's not given anything, then you have to replace this one. If a resistance is given, then you can put it a resistance instead of a diode. That is a mega of magnitude. So let us understand this model. I'm taking the same problem which we have used earlier. Shall I erase this one? So let us erase this one. So say I have a battery of 9 volt, 600 ohm, 300 ohm, and here I have a diode, and this is your 100 ohm. Okay. Now it is given in the question that diode is made of silicon. Okay, so V cutoff voltage for diode is 0.7 volt. It is given, plus a forward resistance also given. Forward resistance value is given 20 ohm. So you need to find how much current is flowing through the ID, that you need to calculate. Now this is like a same question, only you have to put resistance also. So this question we have already solved. You know what is open circuit. So what is the trick for doing this type of questions? You have to make it open and you have to find the VThevenin circuit. So VThevenin of this circuit will be what? This circuit will be equivalent to what? Tell me. VThevenin will be, if I make it open here. So whatever voltage will come here, that will be your VThevenin, because this will be, if you open, this will be ground. This will be ground. Okay. So this will be your VThevenin. So VThevenin is how much? VThevenin will be 9 volt will be divided between 900 ohm. So 6 will come here, 3 will come here. So your V, so this will be 3 volts. So we have already solved this problem earlier. So your VThevenin is 3 volt. Okay. What is the RThevenin? Tell me. What is the RThevenin? Can anyone tell? Can anyone remember what is the value of RThevenin?
300 ohms, sir.
So RThevenin will be, if I make it short, this will be parallel. 300 into 600, 900. And now this will be series with this 100 ohm.
200 and 300.
How much become? 300, na? So 3, 2, 1. So 300 ohm. RThevenin is 300 ohm. So this whole circuit, it's simplified like this. And now open terminal, you can put back the diode again. Silicon. Now you want to find what is ID here. Now you can replace this diode by a 0.7. Now it is forward bias because open circuit voltage 3 volt. It is a forward bias. So you can replace 300 ohm plus 0.7 and a resistance of R forward 20 ohm. So this become how much? 3 volt. And now you can find what is ID in the circuit. So ID will be how much? You have to write. You have to write minus, write the equation, because it is, if I'm coming here, it is becoming a little bit. So minus 3 volt plus I into 300 plus 20, 320 plus 0.7 equals to 0. So ID will be 3 minus 0.7 upon 320. That is 2.3 divided by 320 ohm. Okay, how much is coming? Tell me, current. 7.18 milliampere. 7.18 milliampere. Please check if it is correct. Clear? Now let me do one more problem to demonstrate this model. Say I have a voltage source of say 11.4 volt. So here we have 4 ohm. Here we have a 4 ohm. Okay. Here we have a diode. Here we have a 1 ohm resistor. And here we have a current source of 1 milliampere. Okay. And now diode cutoff voltage V gamma is given 0.7 volt and the forward resistance is given 1 ohm. Okay. Now I want to solve this problem and I want to find what is ID flowing here across this diode. So again make it open here and find the VThevenin here. Find the open circuit voltage here. What is the open? Okay. So V open, that will be your VThevenin. So say this is A point, say this is VA, say this point is VB. So basically your VThevenin will be what? VThevenin will be VA minus VB. Find out. What is VA minus VB? Let me come positive, come and negative, but here I hope to come positive. So what is the value of VA? Tell me. What is the value of VA? Can anyone tell me what is the value of VA? कौन बताएगा VA कितना है? अमरदीप, Yoshita, what is the value of V? Leo, what is the voltage here?
5.9.
कितना? 5.7.
5.7.
Correct. Because this voltage, this current will come here, it will go here. This voltage will divide here. Nothing will go here. Current will not go here. Okay. Similarly, this current will go here, come back here. यहाँ से start होगा, वापस current को वापस आना पड़ेगा because this is open, so current. So here no current is there. So this path is you can remove. So VA will be your 11.4 divided by 8 ohm into multiply by 4. That will come 5.7 volts. Similarly, what is VB? What is VB? So this is sorry, you can make 1 ampere. Make 1 ampere, huh? It's not kilo, 1 ampere. The current will become milliampere. Okay. Now this will become out 1 volt.
1 volt.
1 volt. Okay. So my VThevenin become 5.7 minus 1. That will become 4.7 volt. Okay. Now find the RThevenin. What is the RThevenin? So RThevenin, you have to remove open circuit resistance here.
3 ohm.
RThevenin. So this will be 4, 2, and this 2, and this will be open circuit. So this will be 2, 3. So RThevenin will be 3 ohm. Okay. Now just make it equivalent circuit of given question. This will be your 5.7 volt. R Thevenin is 3 ohm, and put it back the diode like this. Now this diode is forward bias, so you can replace this diode 5.7 3 ohm. This diode is 0.7 volt, and here is a resistance of 1 ohm. Put it back here. Okay, how much will come? Say you want to find ID in the circuit. There is 3 plus 1 4, so you can write minus 5.7 plus 3 ID plus 1 ID 4 ID plus 0.7 equals to 0. Okay,
Sir, V is 4.7 now.
4.7. So कितना आ गया बताओ भाई? 4 ID
1 ampere.
equals, okay, 4 ID equals to 4, so ID equals to 1 ampere. Okay, now if you make everything in kilo ohm, so that will become milliampere. That I didn't do. You can put a resistance value kilo ohm, so it will come milliampere. That's it. Okay, that is your answer. So it is simple method. Diode is very simple. If you understand, just you know how to make the Thevenin circuit. Diode questions are very simple. Nothing is tough. Okay. Now let me do a few more problems which came in exam. Now these are the models. Okay. It's not necessary that question will come with always model. There may be some other voltage. VD may be the voltage drop may or may not be 0.7. It may be higher. You can especially design the diodes which have a more voltage 2.35 something. That depends on what is the junction properties you can design. Okay. So now let me do a few more problems. Then we'll go to the next application. Say this problem came in NET 2010. It says a diode, from a diode current is flowing like this. Okay, so you have been given a circuit of 10 volt. Okay, and the resistance is 1 kilo ohm, and you have been given a diode. Okay, and now it says the current flowing through the diode is equal to V minus 0.7 divided by 500. Okay, for V is greater than 0.7 volt. If V across the diode is 0.7 volt, or 0 for V when V is less than 0.7 volt. Okay. So basically current value is given. Current value is given. And by seeing the current value, you can see this is the voltage drop across the diode. Okay. 0.7, because here diode can be replaced by a resistor also. If I replace this by 507, I can replace this by this one. Okay, so this will become basically my voltage across the diode. So if I know voltage, I can find the current value. Okay, if you don't understand this one, leave it. You just follow what the question says. Question says if the voltage across the diode is greater than 0.7, then current flowing is this one. So tell me the voltage across the diode is greater than 0.7 volt, or yes or no? What is the voltage across the diode? But it's not ideal diode. Okay, just check whether voltage is greater than 0.7 or no. Make it open. And open circuit voltage is greater than 0.7 volt. So that means current is flowing. Current is flowing this one. So I can now write simply minus 10. I can say the current is flowing I minus 10 volt plus current is flowing I into R. R is 1 kilo ohm. And plus here voltage is say V. Here voltage is V. equals to 0. Now you want to find what is the voltage value of voltage, this one. So this will become minus 10 plus I is what? V minus 0 0.7 500 10 Q plus V. Okay, so this become 1, this become 2. So 2V minus 1.4 plus V equals to 10. So 3V equals to 11.4. So V will be how much? 3 point. Tell me how much? 3.8 volt. 3.8 volt. Okay. So the voltage value is 3.8 volt. And now you can find what is the value of current. So current is basically I minus V minus 0 0.7 divided by 500. So 3.8 minus 0 0.7 divided by 500. And this will come out around 6.2 milliampere. Is that question is clear to everyone? Leo?
Yes, sir. Yes, sir. Clear.
So you can see exams questions are very simple of diode. Okay, let me do similar kind of question. One more question. This also came in exam. Gate, I think. So you have this is 10 volt. Here you have a 1 ohm. Here you have a diode. Okay, and this says the voltage across the diode is VD. And question says ID is flowing in the circuit. Okay, VD square plus 2VD equal to this current value. If VD is greater than 0, okay, or 0, and the current is 0 for VD less than 0. Now, if I find the voltage across the diode is obviously greater than 0. Okay, so but I can take maximum. So I assume the current is flowing ID. So now again minus 10 volt minus 10 plus ID into 1 ohm 1 ohm plus VD equals to 0. Put the value of ID minus 10. ID value is VD square plus 2VD plus VD equals to 0. And this gives me VD square plus 3VD minus 10 equals to 0. Okay. Now if I solve this one, VD is equal to 5VD minus 2VD minus 10 equals to 0. So VD plus VD equals to VD plus 5 minus 2 common VD plus 5 0. So VD plus 5 equals to VD minus 2. Now we have already assumed VD is greater than 0. So this value VD equals to minus 5 we cannot take. So VD is equals to 2 volt.
सर आई इक्वल्स टू 0 हो रहा है इसकी केस में सर रिवर्स बायस हो जा रहा है ना सर
हाँ पर रिवर्स बायस तो है नहीं. हाँ पर रिवर्स रिवर्स जगह तो 0 करने दे रहा, रिवर्स तो है नहीं. हम तो देख रहे हैं फॉरवर्ड बायस है, तो ठीक है, करेक्ट, सही. Now we'll go to the applications part. Okay. One application rectifier we have already seen. We have solved the problems also. Now we'll see other applications, which is clipper circuit, clipper clamper, clipper and clampers. Okay. So first put it the clipper circuits. Diode clipper circuits. What is diode clipper circuits? Okay, so these circuits are used to clip off some portion of signal. Okay, clip matlab remove, clip off or remove, clip off or remove some portion of the signal, like rectifier, half wave rectifier is what? It is kind of clipper circuit because it removes the your negative cycle. Okay, so some portion is removed or some portion is a clip, some portion is cut, will cut. That is a clipper circuits. Okay, for example, if I give you example, say again, same half wave rectifier you already seen. So say this is your voltage as a function of time, Vt. Okay, say plus minus, or say plus minus Vt as a function of time, it will be positive negative both. Okay, or say this is now, here we have a diode, and say here is the voltage. I am measuring the voltage here. So this is my input voltage. Okay, we generally we call it source voltage. Now this voltage can be positive negative both, positive negative both. Now I want to draw the transfer curve. Transfer curve is meaning that is output input curve, output voltage. So V output versus V input, V naught versus V as curve are called transfer curve. So for example, if my voltage is positive, if my voltage, and now assume the diode is ideal. So if my voltage is positive, obviously this will be divided by short circuit. So this whole voltage will come here. So for positive cycle of V input, Vs or V input, okay, and this is my V output, there will be always this kind of line. This is called transfer curve, because your output will be always what? Equals to Vs. And negative portion of the curve, if I go to negative Vs, here negative Vs, then this circuit will be open, no current will come, so my V output will be 0. So this is the transfer curve, V output versus V input relation for this given circuit. And now if I say my V input is a sine wave, say my Vs is my sine wave, and I want to plot my V naught. So by looking this graph, I can easily find, because for positive part, my output is also same like my V input, and negative part 0. So this will come like same like here, and it will come 0. Now it can be triangular wave, it can be square wave, anything you can plot. Once you understand the transfer curve, you can plot this curve very easily. So this is the one kind of example of clipper circuit. Okay, so it is removing negative part of the wave. Okay, now let me take some more example of clipper circuits. Is that clear to everyone?
Yes, sir.
Yes, sir.
Now what I'll do, I'll put a resistance here, and I'll put a diode here. Resistance could be maybe anything. You don't require the values. Okay, because I'm plotting output only, V output only. So tell me now, what is the what is the curve? Okay, what is the transfer curve for this circuit? So transfer curve for this circuit will be, tell me, if it is the V positive, if Vs is positive, then what is the value of V naught? What is the value of V naught? This is an ideal diode.
0.
0.
0, 0. So it will come 0. The positive part, this will become 0. And negative part, what is the value of V naught? So for positive
Vs.
cycle, very good. For positive cycle, V naught is equals to 0. For negative, not cycle, here for positive value. For negative value, for positive value of Vs. For negative values of Vs, my V naught will be equal to Vs. So for negative side, my Vs is negative, so my V naught will be also negative. So this will be the curve. This will be the curve. And now if it is sine wave, you can plot very easily. If it is my Vs, and if your V naught, positive cycle, you are not getting anything, you are getting 0. And negative part, you are getting negative, same like this one, V, because V not equal to Vs, so you're getting the same thing. So this is your clipper circuit.
So can we consider the filter circuit as the clipper circuits?
No, filter generally removes the part of frequency. Okay, not this one. It filters the signal with according to frequency. Okay,
Okay,
not like
sir.
this. Now same circuit, if I say this diode is ideal silicon, okay, now you tell me how the transfer curve will look like. Tell me. How transfer curve will look like.
So it will be the difference of 0.7 and Vs.
No, I want V naught, na. So when my Vs is less than 0 for positive values of Vs. First, I'm taking positive part. If my Vs is less than 0.7 volt, then my V naught will be equal to, tell me.
Vs minus 0.7.
Why 0.7? If my Vs is less than 0.7, it is open or close?
So it is open, na? In that
Open.
case.
तो open में क्या आता है? Same
Vs.
like Vs. Same like
Yes.
Vs.
Yes, sir.
No current flowing. So this will V naught will be Vs. So up to 0. So up to here 0.7 value. This curve will be same like this one. When Vs is greater than 0.7, then V naught will be. Then V naught will be forward bias or reverse bias?
Forward bias.
Forward
And
bias.
forward bias means now
Zero
it
हो
will be
जाएगा.
replaced by. It will be replaced by battery of 0.7 volt. So V naught कितना हो जाएगा? 0.7.
7.
It will be always fixed like this. Okay. What happened? What about the negative cycle? Tell me. Negative cycle. For negative cycle. For
V naught is
negative
equal to
value.
Vs.
Yes, negative value of Vs. V naught will be always Vs. If it is negative, it will remain negative. So this curve will continue for negative values. Okay. For negative values. Okay. Or we say when Vs is less than 0. then V naught is always equal to Vs. If it's negative, it will be negative. That's the curve. And now if you want, you can do it for sine wave. Because so this is my sine wave. And now initially it is same like up to 0.7. So this is the V max. We don't know what is the V max. Okay. So up to here at least 0.7 volt. It will be follow same thing up to here. It will be same. And then it will be fixed. So until this Vs is greater than less than 0.7, you get same thing. When it is above, you get this one. So here, so these are transition points. So whenever Vs become less than 0.7, it will come like the same like this one. And then after that, it will follow same like this one. This is your V naught, and this is your Vs. Okay. Now, let me put a few more graphs for your practice. Now, if I say my diode is like this, and here you have a resistance of 1 kilo ohm, V naught, this is silicon. Okay. Plot the transfer curve. Plot a transfer curve. So when for Vs is positive, okay, when Vs is positive, this is V naught, Vs is positive, what will happen? Tell me. V naught will be always reverse bias, so V naught will be equal to Vs. Okay. And for Vs less than 0 part, what will become? V naught will be equal to, tell me what क्या आएगा बताओ? Reverse cycle, this become plus, this become minus, current will flow like this. So negative part. If my Vs is less than 0.7, less than minus 0.7 in magnitude, okay, so what will happen? That time this will be open because it requires 0.7. So this will be open. So your V naught will be equal to again equal to Vs, the same thing, negative cycle. And for and if Vs is greater than बोलेंगे, less than बोलेंगे, is greater than बोलेंगे, greater than 0.7 मतलब छोटा है, and Vs is less than 0 minus 0.7 volt, then this will be replaced by a battery like this, okay, and my V naught will become minus 0.7 volt. So what is the meaning? Positive cycle, this is always like this. For negative cycle also, it will be open until this become greater than minus 0.7 volt. So Vs is here greater than minus 0.7 volt. When my Vs become less than this one, then this voltage become fixed to up to what? Minus 0.7 because of opposite battery. So V naught become minus 0.7. Okay. Is that point is clear to everyone? Karishma? to say if it
सेकंड
is
वाला
si-
पार्ट थोड़ा सा फिर से बता दीजिए सर.
so suppose this is a sine wave. Positive part, you have always diode reverse bias, you get same thing. Negative part, until you don't come minus 0.7 volt, because the diode is like this, na. So you have so if this minus value, if now suppose this is a minus, this is BS should be at least minus greater than minus 0.7 volt. It should be less than this one. Then only it will be on. If this is not, the value is not sufficient, because it has to be forward bias, not is minus plus. If my Vs is greater than minus 0.7 volt, that means Vs is somewhere here. Then this cannot on. When my Vs goes, okay, Vs goes the below Vs goes the value of less than this. This is minus 0.7, minus 0.7 value. So when my Vs goes less than this value comes here, then only it will be on. It will replace a battery. It's like this simple thing. Because negative cycle maybe it has to on. Na? So this will be up to here, it will be same, and then it will be fixed, and then again it will be same. Again it will be same here up to here, and then it will come down. Exactly opposite what we done earlier. Leo is clear?
Clear, sir.
Okay. Let me plot a few more graphs.
One minute sir. Done sir.
Say if I have one here, say this is my VS, this is my diode, so this is R, so this is voltage VB here, and this is my V naught here. Okay, this is the resistance R, this is the ideal diode. Ideal means you have to replace by short circuit. Tell me now, transfer curve for this one. This is V naught, and this is VS. Tell me what is the transfer curve. So this VS, so this diode is forward bias or reverse bias?
Forward biased.
Why? Battery BB also there, na? So for positive cycle, for positive part, for Vs greater than 0 part, if my Vs is less than VB, then diode is forward bias or reverse bias?
Reverse bias.
Diode is reverse bias. Diode is reverse bias. That is open. And when this become open, what is the voltage V naught equal to? Tell me, what is the voltage equal to? So if it's open, so when it's open, then V naught will be
VS minus VB. VS
V-
VB
V-
minus VS.
ये तो सर्किट में है नहीं ना, ये तो ओपन हो गया यहाँ से, तो वी नॉट कहाँ आएगा, यहाँ से आएगा ये वाला।
आर के क्रॉस कितना आएगा पोटेंशियल?
आर आर ये तो ओपन सर्किट, देयर इज नो करंट इन द आर।
सर
there any current
V0
in
इक्वल टू VB।
VB? V0 equals to VB, very good. So until my V input VS is less than VB, if it is my V input is less than VB, then this no current is there, so this VB is coming here, so this VB will come up to here, so my output will be VB. After that, what will become when VS is greater than VB? I'm talking about the positive part. When VS is greater than VB, then diode become forward bias. Diode is forward bias. Forward bias का मतलब क्या है? Short.
Short circuit.
Short हो गया तो ये हो गया. अब V नॉट कितना हो गया?
VS minus VB.
देखो अच्छे सर्किट में देखो, V नॉट इक्वल्स टू ये पूरा कितना होगा?
VS.
VS ये पूरा यहाँ आ जाएगा, तो ये VS क्या होगा? VB प्लस IR, ये पूरा का पूरा इसमें आ जाएगा. सो आफ्टर दैट दिस वन योर V नॉट विल बी इक्वल टू VS लाइक दिस. Okay. Now second part you do it for VS less than 0. For VS
सर
less than हाँ
सर मैं ये जगह समझा नहीं। जब VS ग्रेटर देन VB हो रहा है तो
हाँ
डायोड तो शॉर्ट सर्किट की तरह बिहेव कर रहा है, तो
शॉर्ट
वोल्टेज ड्रॉप।
शॉर्ट सर्किट हो गया,
हाँ
तो ये
हाँ
वोल्टेज सीधा सीधा यहाँ आ गया,
हाँ
ड्रॉप
हाँ
है ही नहीं. तो ये V नॉट
हाँ हाँ
ये V नॉट क्या हो गया? VS हो गया ना. तो यहाँ पे अगर 10 वोल्टेज है तो 10 वोल्ट यहाँ आ गया, तो ये V नॉट क्या हो गया? 10 वोल्ट हो गया. अगर ये 11 है तो 11 हो गया, 12 तो 12, 13 13, तो जो वैल्यू इसका आएगा वही का वैल्यू वही इसका आ जाएगा आगे.
ओके 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 ओके।
Okay. For VS negative, diode is, if it is diode is forward bias or reverse bias? So VS 0.
Reverse biased.
Reverse always, because it's already making reverse bias, you put in more negative, you become more reverse bias. Diode is reverse bias. Okay, reverse bias मतलब ओपन हो गया तो नो करंट हो गया. ओके, तो मैं V नॉट कितना आ जाएगा?
VB.
VB always. So this will continue for negative cycle. VB. Okay. Now make it for sine wave. If it is sine wave, what will happen? If it is sine wave, this is my V out VS, and I want to plot for V naught up to VB. It is VB up to here. This part I'll get VB. After that I'll get as it is. Okay. After that I'll get as and then it become one less. Again I get VB up to here. Up to here VB, and it become negative, then also I have a VB. Then also I have a VB. Okay. So this is my answer. Now this is your diode. Okay. And say I am putting a battery here, VB. Banao bhai. Make it. Transfer kar. Say diode is ideal. For positive, Vs is positive. Okay. Again, here, sorry, you have to put register. Is ideal. Now again, you see this diode is reverse bias by VB. Until this Vs is less than VB, diode is reverse bias. Reverse bias means it is open. So one become open. This is the ground. This battery is not in the part. This battery is not in the circuit, and this V naught will come equal to Vs. V naught will come to Vs. Okay, and similarly when Vs is greater than VB, when Vs is greater than VB, then this diode becomes short circuit, and my V naught will become equals to VB. This VB will come V naught. Okay, so here up to VB, after that it is fixed VB. This V naught Vs. And for negative part, what will become? Negative part always negative, always open. Vs negative. Diode is reverse bias. So when you get V naught equals to Vs, it will be following same thing. Same thing. Okay, one more question. Two more questions are there. Both have come on exam. Can I rub this one? Is it clear to everyone?
Just 1 minute, sir.
Hmm.
Okay, sir.
Do you want break? 5-minute break you want?
Yes, sir.
Okay. We'll take break and then we'll come again. So now this is 7:30. Okay. So we'll come at 7:35 p.m. Okay, welcome back. This can be anything R. No need to put the value Vs. Say I have this diode. This is this diode. Okay. Tell me. What should be the curve? So for Vs equals to positive value. For Vs positive. Okay. Which diode is open? Which diode is conducting? Say this
First
is
one
D1.
First one
Conducting.
diode is conducting and second
D2
one is not conducting.
Open.
So Vs is greater than 0. Okay. D2 is always open. And this may conduct, but the condition is there. Vs should be greater than 0.7 for what? Okay. If Vs is less than 0.7, both D1 and D2 are reverse
Open.
bias. Okay. But when Vs is greater than 0.7 volt, only D1 is forward bias. Understand this one, huh? D1 is forward bias and D2 is reverse bias. Okay. Both are a reverse bias. So if I plot this one, and when this become forward bias, this will become battery of 0.7. So this voltage will come as it is here. So when both are open, you will get like this. Up to here, you get 0.7. 0.7. And after that, this will fix 0.7. Same thing happened in negative. For Vs is less than 0. Negative part, if Vs is greater than minus 0.7 volt, okay, reverse bias means V not equal to Vs. V not equals to, so Vs is less than 0.7 volt, both are reverse bias, both are reverse bias, so V naught equals to Vs. And after that, when Vs is less than equal to minus 0.7 volt, okay, then V naught will fix to minus 0.7 volt. And here V naught will fix to plus 0.7 volt. So this will be minus 0.7 volt. Okay, this is very important question. Couple of times this question came in exam. If you have doubt, please ask me. Is that clear to everyone? Okay.
Yes, sir.
Now sine wave. Plot this for sine wave. You have a sine wave. This is Vs. You want V output. So this will be like this. So up to 0.7, it will be clipped to 0.7 and minus 0.7. It will be clipped here and here. Okay, after that, this will be clipped, this portion will be clipped. This portion will be clipped. Up to here, it will come same. Up to here, here, and here, it will come same. So this portion will be clipped. Okay, let me do one more problem. This will be the last problem for clipper. Say I have a register. Okay, I am putting a diode here, and this is I am putting 2 volt. I am putting a diode like this, and this is also minus plus 1 volt. R. Here you have a Vs, which is changing with time, and here you want to write V naught. Okay, so you have to find the range for which V naught equal to Vs. Question is asked in the exam, GATE exam. Find the range of Vs. Find the range of Vs for which V naught is equal to Vs. Find the range.
Sir, what is the nature of diode, sir?
Silicon. 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 Now, if you have a Vs is positive, okay, again you say this is D1, D2. D2 is always reverse bias. Okay, so Vs is greater than, Vs is positive, D2 is always reverse bias. D2 is always reverse bias. But this is also reverse bias up to 2 volt. So when Vs is greater than 2 volt, then what will become greater than 2 plus you require this 0.7 also. Are you getting my point? This diode is reverse bias by 2 volt, and this itself is silicon, so it requires 0.7 volt to conduct. So this Vs has to be greater than 0.7 volt to make this diode conduct. And a positive cycle, this is always open. So until this Vs doesn't reach 0.27 volt, this whole part is open. So you can plot a curve like this. Up to 0.7 volt, Vs is equal to 2.7 volt. Positive value Vs, both are open. Okay, until Vs is less than 2.7 volt, both D1 and D2 are reverse bias. Okay, and on Vs, so V naught equals to Vs. When Vs greater than becomes 2.7 volt, D1 conducts. And when D1 conducts, this become like a battery. So this is 0.7 and this is 2.7. Total 2.7, this will become fixed. What happened in the negative cycle, tell me?
Sir, minus 1.7 volt, sir.
Yeah, and for negative cycle, Vs is less than 0 and Vs is greater than minus 1.7 volt. For this case, your V naught is equal to Vs. Okay, because in negative cycle, you want to make this conduct. Okay, so this is already reverse bias. So negative cycle should come 0.7 plus this 1.7. So 1.7 here, and now after that becomes 6. So this is minus 1.7 volt. And after that will become, when Vs is, this is Vs is greater than, Vs is less than minus equal to 1.7 volt. My V naught will become minus 1.7 volt, and here V naught will become 0.7 volt. Okay, so you're asking for find the range for which V naught equal to Vs. So the range of Vs will be minus 1.7 volt to 2.7 volt is in this range. Okay, if this is minus 1.7, 1 minus 1.7 volt for this range. Okay, you got V naught equals to Vs. So this was your clipper circuits. Okay. I'll start clamper today also. Okay, we'll not complete, but some simple circuit of clampers also we'll discuss today. Okay. Let us discuss now clamper circuit. Is this clear to everyone? Aparna?
Yes, sir.
Okay.
Yes, sir.
Now clipping means removing. Clipping clipping is doing what? Clipping is you can put make it for sine wave also. The same curve. So clipping is what doing? Clipping is removing some portion. It is distorting my signal. Okay. Now clamper is somewhat different. What does clamper do? Okay. So if you do diode clamper circuits, diode clamper circuits. Okay. Diode clamper circuit means these circuit will shift the level of these circuits will shift the level of signal. These circuit will shift the level. It will make it level up and down on the from the zero reference value. Okay. Now clamper circuits are two type. One is called positive clampers. Another is your negative clampers. Okay. Now first we'll discuss positive clamper, which will shift the level up. Okay. This will shift the level up. Okay. Shift the signal level up. Okay. These will shift the signal level below to the reference value, below to reference value shift the signal level up above the reference value, Now let us understand the clamper. First we'll take say positive clamper. Okay. First discuss positive clamper, then we'll discuss the negative clamper. So put the heading positive clampers. Positive clamper circuits. Positive clamper means so you have to understand, you want to shift the level up. Okay. So a clamper circuit involves a source. Okay, say AC source Vs, which is Vp sine omega t. It involves a capacitor and a diode. So if I want to shift the level up, I have to, then the current in the diode should flow up. Okay. So if the shifting will always happen in the direction of the current, how the current is flowing across the diode. So if current is going up, then it will stop. If current is going down, if I reverse that polarity, then current will come down. So it will be shift the level down. So that way you can remember. So this is I'm making positive clampers. I want to shift the up. So this is the basic circuit. It involves capacitor, diode, and if you want, you can put a high resistance RL, load resistance R or RL. And here you are taking the V output. And this the capacitor is C. Now this resistance is very high. Okay. Now what happens for positive cycle? So the first thing you to understand, the condition for clamper is that RC should be greater than the time period of the signal. This is the condition for clamper. Okay, for clamper circuits. Okay, RC means this R and C value should be greater than the time period of the signal. Time period of the signal means this is my signal. And the signal time, this is my signal time period. This time period should be less than the RC. If RC is, so you know the equation. What is the equation for discharging of capacitor? VC equals to V naught e power t upon tau. Tau is what? RC. If RC value is very high, then what will happen? The discharging will happen slow. If RC value is low, discharging will happen very fast. So I want my RC should be greater than the time period of this one. So, so in this, the time period of the signal, my capacitor should not become discharged. It should maintain its value. That's why the RC of the circuit, RL into C, RC means RL into C, should be very high for the circuit. This is the condition. Now the question is, how does it work? Now how shifting happens? So when for positive cycle, this capacitor will start charging, and capacitor will start charging. So this plus, this is plus. So this diode will become reverse bias. So this diode will become open. So this diode will become open. Then, but now what will happen? Current will flow through the resistor. Yes or no? If this positive cycle, suppose I'm applying a positive cycle of V input. For positive cycle, my capacitor will charge like this. Slowly it will charge. It will charge up to the peak value Vp. But what will happen when this capacitor is charges? Some voltage will drop here, some voltage will drop here. But this resistance is very high, so the capacitor will not charge. Capacitor will not charge up to the peak value Vp. So because here diode is not conducting, so this cycle we should not take. Now, so capacitor will not charge in this cycle, because when this charge, current is passing, it is open, current is passing through all current is passing through here. So all voltage is getting developed, drop here. So this is not charging. Now capacitor will charge only when in the negative cycle. Negative cycle, when the current flows like this, that time what become? This becomes short circuit. And all the voltage of this input will develop here. So always first you have to see in the circuit which direction capacitor is charging. So capacitor will always charge in the diode direction current, because in this case only it will fully charge. Otherwise, all the voltage will develop here. This will not able to charge. So capacitor will charge here, and capacitor will charge up to what? The peak value of the diode. Now this capacitor is charged. This is the final condition of the circuit. It will take a few cycles. Okay. So in the positive cycle, capacitor does not charge. So you can write for positive cycle, capacitor does not charge, does not charge fully, because all the voltage gets dropped across RL. So it will charge only the negative cycle. So it will show for negative cycle, capacitor charge for this circuit charges to Vp, to up to charges to peak value of the signal, charges to Vp of the signal, Vp of the signal. Now once this becomes charge, this is Vp and this is Vs. Okay, now first we have to decide which cycle it is charging. Now we have decided this will charge only like this, and once this is charged, while charging it is short circuit, it is allowing current. Now what happens once it is charged? Now when it is get charged, now this Vp is making this will work like a battery, and this Vp is making this reverse bias, and this source is making it forward bias. For positive cycle, this is always reverse bias. Negative cycle, it is making it forward bias, and this making reverse bias, because Vp is always greater than Vs. So final circuit, final steady state, this diode is always open. So this diode, after once it is charged fully, this diode will also become open. Now this is my final condition of the circuit. Now I have to find what is V naught. This is my Vs. So I will write here, say minus Vs minus Vp, and this is my V naught equals to 0. So my V naught will be what? V naught will be, tell me how much? V naught will be what? V naught will be Vs plus Vp. Vs plus Vp. Okay. Now I want to find my output. So this is my Vp. So when my Vs is 0, when Vs is 0, my V output is Vp, and my when Vs is Vp, my V output is twice of Vp up to here. This is Vp, so this is twice of Vp, so my current will go up to here. When it is 0, I am up to here, Vp. Okay, and when it is minus Vp plus Vp, I am at 0. And when it is go to 0, again goes to here, up to here. Okay, so this is your clamping. The level now the 0 is what? 0 is here. Here the reference level. So this is shifting the signal. Earlier this is 0. Now this becomes shifting by the signal by Vp. Okay, so this is called positive clamper. Okay, this is your positive clamping. Tell me if you not understood.
सर एक बार आप पॉजिटिव साइकिल के लिए बताना कैसे चीजें होती हैं
पॉजिटिव साइकिल में क्या होगा? पॉजिटिव साइकिल में ये ऐसा चार्ज होगा, ठीक है? पॉजिटिव साइकिल के लिए ये ओपन हो जाएगा, डायोड रिवर्स
sir.
बायस है, तो करंट कहाँ फ्लो करेगा? यहाँ फ्लो करेगा, तो वोल्टेज ड्रॉप यहाँ पर होगा और यहाँ पर होगा, पर ज्यादा वोल्टेज ड्रॉप कहाँ पर होगा? यहाँ पर होगा, क्योंकि आरएल ज्यादा है, तो यहाँ ये चार्ज फुल्ली होगा ही नहीं, ठीक है? नेगेटिव साइकिल में क्या हो जाएगा? ये शॉर्ट हो जाएगा, तो करंट यहाँ जाएगा ही नहीं, तो करंट कहाँ से जाएगा? करंट विल गो लाइक दिस, एंड बिकॉज यहाँ ड्रॉप 0 है, तो लेवल में सारा का सारा चार्जिंग कहाँ जाएगा? यहाँ तक। तो हमको ये जहाँ पे ये चार्ज हो रहा फुल्ली, वही साइकिल देखनी है। और
so,
एक बार
V नॉट Vs के बराबर हो जाएगा पॉजिटिव साइकिल में?
पॉजिटिव साइकिल में हाँ, V नॉट Vs के बराबर हो जाएगा। वेरी
ओके
गुड।
सर ये यूज कहाँ होता है सर? जैसे पिछला वाला था सर, वो हाफ वेव रेक्टिफायर के सर।
और डिफरेंट एप्लीकेशन होती है जहाँ पे भी आपको सिग्नल को शिफ्ट करना होगा कम्युनिकेशन लाइन में, ठीक है। सिग्नल्स को अप एंड डाउन शिफ्ट करना जरूरत पड़ती है क्लैम्पर सर्किट में, वहीं पे यूज होते हैं ये लोग। तो इस पर नहीं आते हैं अभी, पहले सीख लेते हैं कैसे करते हैं, बाद में इसकी थ्योरी डिटेल समझेंगे कि क्या कहाँ क्या होता है। पहले तो सीख तो जाओ एग्जाम के लिए, ठीक है।
ओके सर।
So now this is positive clamper. Okay, now let us discuss negative clamper. Negative clamper means this is your Vs always capacitor here. Negative मतलब करंट नीचे फ्लो होना चाहिए, current should flow नीचे, current should go down. This is the negative clamper, and this is what, this is your RL, which is very high voltage. So now for positive cycle, this is short circuit. Okay, for positive cycle diode conducts, for positive cycle diode conducts, and capacitor charges to its peak value, and capacitor charges to its peak value. ये चार्ज हो जाएगा, कहाँ तक चार्ज हो जाएगा, ये यहाँ तक चार्ज हो जाएगा, Vp तक। और यहाँ और नेगेटिव साइकिल में तो ये ओपन सर्किट है, तो यहाँ वोल्टेज ड्रॉप सारा हो जाएगा, तो चार्ज ही नहीं होगा। तो हमको वी टू टेक ओनली दिस साइकिल, एंड वंस इट इज चार्ज फुल्ली, दिस इज मेकिंग रिवर्स बायस, this is making forward bias, this is always greater than this one, so this will become open. This is open. Now you have to write the equation. The equation is minus Vs, Vs can be positive negative both, okay, plus Vp plus V naught equals to 0. V naught is equal to Vs minus Vp. Okay, so this is my output. Plot the output. This is your V input, and you have to plot the output. बनाओ output बनाओ अभी, कैसा आएगा? So the equation is now this one. इसमें वैल्यू पुट करते जाओ बस, और क्या। V naught, when Vs is 0, my V naught is minus Vp. Here, when Vs is Vp, this is 0. Okay, and when this is minus Vp, this is goes to कहाँ तक जाएगा, minus 2Vp. So when this is Vp, it is 0. It is 0. It's come back to here level this one, and when it is minus, it is goes to here. Okay, and it's come back to here, and then it is continue like this. So this is now level becomes shift to minus Vp. Earlier it was there, it come down by minus Vp. So this is your negative clamper. Okay. Clear? So do you want to continue some 10 minutes more or should I stop? Amanpreet.
तो sufficient है आज के लिए.
Okay. So let's stop here. Tomorrow we'll see some more biased clampers. Okay. This was simple example. अभी किसी को नॉइज नहीं समझ में तो बता दो, otherwise we'll stop. Tell me if there's any doubt. Karishma, is clear? Kashish?
Yes, sir.
Okay, we'll stop here.
Thank you, sir.
Thank you.